Okay, question 1. This question, I'm using matrices to balance this chemical equation. All right, let's see if focus here. Okay, so I have 4 terms here, okay? And you want each side to have the same amount of elements as each other. So I added a coefficient in front of each term so that I can multiply it by a certain number, each term by a certain number, so that each side has the same amount of iron, each side has the same amount of oxygen, each side has the same amount of carbon. So first things first, I set up each equation separately, I set up each element separately with an equation. So I know that there's 2 irons in the first term, and that equals 1 iron in the third term. I know that there's 3 oxygen in the first term, and it adds with 1 oxygen in the second term, then equals 2 oxygen in the fourth term. And then carbon, there's 1 oxygen in the second term and 1 oxygen in the fourth term. So for my matrices, I set it up. Each column is, so first column's x1, second's x2, x3, x4. And I set each equation to equal to x4. So oxygen and carbon are already equal to x4, so I don't have to manipulate the equation at all. But with this one, right now there's technically a 0 x4 here and a 0 x2. So what I did is I subtracted x3 from both sides to get it onto this side so that it only equals to x4. And that will get you 2, 0, -1, and 0. So first step for the matrices, I looked at the 3 by 3 square, which is what I want, and I know I have to get the 3 diagonally to equal to 1 and the ones around it all to 0. So I'm going to start with the ones around it. So first step, I subtracted row 1 by row 2, and I multiplied it by -1, okay, getting me to this step. And then I subtracted row 2 by 3 row 1 to get me to this step. That created the 0 here. Next, I added 2 row 3 plus row 2, and that got me this 0 here. And then I also multiplied row 2 by -1 to get rid of all the negatives, because I don't like negatives. And then I just added row 2 by row 3, which got rid of this 3 here, made it 0. Next step, I added 3 row 1 plus row 3, getting this to equal 0. Then I added 2 row 1, or I subtracted 2 row 1 minus 3 row 2, also making this a 0. And now that I have all my zeros in place, I was then able to just divide each row. So I divided the first row by 6, giving me this 1, row 2 by 2, giving me this 1, and row 3 by -1, giving me this 1. So I came up with x1 equals 1/3, okay, x2 equals 1, and x3 equals 1. And you can set x4 to whatever you want, so I made it equal to 1. So I have 1/3 Fe2 times O3 plus CO equals, or whatever this means, 2/3 of Fe plus CO2. So one of the rules that I found was that you can't have like a fraction. So I multiplied each term by 3, giving me 1 as the coefficient here, 3 is the coefficient here, 2 is the coefficient here, and 3 is the coefficient here. And to check, there's 2 iron in the first side, and there's 2 iron on the second side. There's 3 oxygen plus 3 oxygen, that's 6 oxygen, and then 3 times 2 is 6 oxygen, and there's 3 carbon and 3 carbon. So I know that this side equals this side, and I have successfully balanced this equation. So for the second part, it's the same thing. Here's my equation. I set up each element and created an equation for it. So same thing, 7 there's 7x1, there's 7 in the first term and 7 in the third term. This one, there's 8 in the first term, 1 in the second term, 5 in the third term, and 2 in the fourth term. This one, there's 1 in the second term and 3 in the third term. This one, there is 3 in the second term, 6 in the third term, and 1 in the fourth term. So to do a matrices, you have to have it like a 3x3 square. So I found out that I actually don't need this equation here. I don't need one of the equations because I can solve using the other ones, and it'll actually work out for this. So I just completely took out hydrogen just because it's the most complicated equation. And then I did the same thing. I set each one, so this is column 1 is x1, x2, x3, and x4. I set them all to equal to 0, so I subtracted 7 from this one. This one was, I subtracted, this one here, I subtracted 3 to get it to equal to 0, and this one I subtracted 6. All right, and then I went through my matrices steps. So I subtracted row 3 by 3 row 2. I then added row 2 plus row 3 to get to this. Then I added row 3 row 1 plus 7 row 3 to get rid of the negative 7. Then I realized that I had it just like I wanted, so I divided row 1 by 21 to get rid of the 21, and I divided row 3 by 3 to get rid of the 3, and I came up with x1 equals 1/3, x2 equals 1, and x3 equals 1/3. I set x4 to equal to 1, and I came up with this equation, and you can't have fractions, so I multiplied each term by 3, so this coefficient became 1, this coefficient became 3, this coefficient became 1, and this coefficient became 3. And to check it, you have 7 carbons in the first term, 7 carbons on this side. 2 hydrogen plus 3 hydrogen is 5 hydrogen. You have 5 hydrogen on this side. And N, you have 3 N's on this side, so you have 3 N's, and there's 3 times 3, so that's 9 oxygen. You have 6 plus 3 equals 9. Alright, so that's my matrices, so I'm going to go to question 2 now. I did question 2 first. Alright, so basically, I'll explain the situation. You and 2 people start from this point right here. One guy, and there's a taco cart, positioned right here. One guy walks straight across the sand. This is sand and this is the road. So one guy walks straight up the sand, and this guy just goes, and he goes across the road. This guy just goes straight through the sand. You can travel 2 feet per second through the sand, and you can travel 5 feet per second on the road. I had to figure out where I should walk to so that I can beat both times. So first thing I had to do was I solved and I found both times. So time equals distance over velocity or speed. And this guy took 325 seconds and this guy took 275 seconds. All right. So I set up my equation. So this was just me solving for the hypotenuse so I could plug it into here. Anyways, I then need to set up an equation involving both terms. So I know that time equals distance over velocity. So first, he's going to be walking some distance over the sand. And some distance is chosen by how far off, how long this will be, how long this x term will be. So whatever this is 325.6 the square root of 325.6 squared plus x squared, right? So that's just Pythagorean theorem solving for this distance. And then whatever I get from that, I divide it by 2 because it's 2 feet per second. For this one, 562.6 minus x all over 5. So 562 is the length of this. You subtract whatever x is, and that's how far he'll be walking this on the road. And divided by 5 is because he travels 5 feet per second. So then I have that equation. I then find the derivative, which is 1/4 of 325.6 squared plus x squared to the power of negative 1/2 times 2x minus 1 over 5. So that's just using simple derivative rules. And then I set the derivative to equal to 0, and I then solve for the minimum, or the time that, the minimum time, or the minimum distance. So I get x to equal to 142.1. I then plug in 142.1 into my original equation that is solving for time, and I come out with 261.7, and yes, that is indeed faster than both those times, so I know I'm right. And by going 142.1 feet off the straight line, you will get the fastest time possible to the taco cart. Okay, for the second part, you had to position the taco cart in any position so that all 3 make it to the taco cart at the same time. So the first thing that went through my mind is either putting the taco cart right where they are or directly straight so that their paths have to be the same, because this guy's not going to walk this way. He's not going to go like backwards and forwards. They're all just going to walk straight to the taco cart. So yeah, that would work. But like you said, it's not really in the spirit of the question. So I set it up so that so I have y. How far does y have to be? It's the same thing as x, but I want both their times to equal each other. So I set up each equation, and I have this guy's time, which is 325.6 divided by 2, which is how fast he'll travel here, plus y divided by 5, which is how fast he'll travel here, equals the square root of 325.6 plus y squared divided by 2. That's how fast this guy will walk here. So if I can find out what distance these 2 people will have to travel, the third party can just travel along the same path as another person so that they all get there at the same time. So what I did was I squared both sides to get rid of the square root, because I do not like working with square roots. Sorry. The first step I did was I multiplied each term by 10. So I simplified this, and then I got this number, multiplied this by 10, so 10 on the top, this cancels out, and this will equal 2. 10 on the top, this cancels out, and this will equal 5. And then I squared both sides to get rid of the square root, and I came up with this line. Then I foiled this term right here. So I did basically what I did up here. I did 2 brackets, and then I foiled it to come up with this line. And this line I also foiled. And then I brought over this actually equals this, so they both cancel out, because if you subtract them from both sides, it'll cancel out, leaving me with this number. And I subtracted 4y squared by 25y squared, leaving me 21y squared. And then I divide both sides by y. Dividing this side by y, I can cancel at the bottom, leaving me with 1y in the top, so it just equals y, and 310 equals y. So therefore, if you go 310 feet off the, I don't know, whatever this point is, 310 feet, both these guys will make it at the exact same time. And to prove that, so to make the third party, I would just have him follow this guy. But to prove that you can also have the taco cart straight ahead, you can set y equals to 0 and solve, and 0 equals 0.